Broadcast is now starting. All attendees are in listen-only mode.
Well, good morning, good afternoon, good evening, wherever you are in the world. Welcome to the Db2 Night Show, episode number 208. I'm your host, Scott Hayes, president and founder of DBI Software, an IBM Gold Consultant and IBM Champion. Our special guest today is Michael Krafick. He's also an IBM Champion and a senior lead DBA. I'll let him tell you more about that when he gets going. Today's topic, 10-minute triage, troubleshooting Db2 LUW production issues. And this presentation comes all the way from IDUG, Australia, where Michael was very successful in fighting off kangaroos and hugging koala bears. Michael, how are you today?
Good morning, Scott. I'm doing well.
Well, that's good. That's good. Did those bruises heal from when the kangaroo dropped back on its tail and punched you?
Yeah, but it wasn't too much of a fight. I mean, I got up and knocked it out once or twice, and it ran away. So it's not that big of a deal. I had my honor to protect with everybody putting the $50 on the kangaroo before I left.
That's right. That's right. And this picture on the screen now, where are you?
We are on top of a huge, what was it? It's not the Sydney Harbor Bridge, was it?
Yeah, the Sydney Harbor Bridge.
Sydney Harbor Bridge? Yeah, we were on top of the Sydney Harbor Bridge, which was an awesome accomplishment for me considering I am petrified of heights. I can go up to the second floor of an escalator and scream like a 4-year-old little girl. So the fact that I was able to hook up and climb to the top of that thing to see the beautiful overlook was really a big accomplishment. That and the fact that I knew I had Scott Hayes behind me, and if I chickened out, he was going to take pictures and put it on Twitter. So I'm glad I got to the top.
That's right. That's right. There's the opera house, or part of the opera house down there in the background behind you.
Mm-hmm.
So this is exciting. Let's get the show going here. Db2 Night Show's a show for the Db2 community. Follow us on Twitter. Mention at Db2 Night Show and at Krafick if you do any Twittering. We'd love to hear your community engagement. Join the LinkedIn group for the Db2 Night Show. If you haven't yet, you can get there by going to bit.ly/join Db2 Night Show. We talk about upcoming shows, things you'd like to see on the show, things like that. Here's the show disclaimers, etc. I don't know. I'm not in the mood to read them today. I'm going to save time. Mind your manners, and we're recording, etc. Tonight's show, a few quick announcements. We'll get into Mike's really awesome presentation. At the breaking point, we'll do some studio audience polls, have a quick commercial. Got to feed the sponsors. And then we'll wrap up like we always do. It's going to be great. Upcoming events. Hey, this afternoon, don't miss this. 1 o'clock Central Time, 2 p.m. Eastern. Find this on DBI's events page. We've got another one of our really cool, fun webinars. See what you're missing. How to tune DB2 in minutes with confidence. It's educational. And of course, there's a little bit of marketing too. But we give everybody a $10 Amazon.com gift card just for showing up and being in our audience. So if you like free money, get in this webinar. Go to dbisoftware.com/events.php. Next, if you haven't heard, iDoug is just 1 week away in Malta. So you can find information here, idoug.org/EMEA 2018. Big anniversary party, 35 years of DB2. It's going to be a great conference. Regretfully, I will not be able to be there. Upcoming shows on the 30th of November. We got Klaus Brandt talking about the perfect Db2 LUW server. Klaus gets into monitoring techniques, configurations, registry, DBM, DB configs, settings for the servers. It's just all about how to have an awesome server for DB2. And on the 21st of December, we're going to have our eggnog party with Martin Hubel, and he's going to talk about indexes versus prefetch, how to win the fight. It's also his really awesome iDoug presentation. On the mainframe database side, 16th of November, I suppose this might be applicable to everybody, machine learning exploitation with Terry Purcell, IBM. 14th of December, Christian Malero. Distributed access to DB2 for ZOS, the most important things you need to know. So some great shows coming up. Check our homepage and get details and register for those shows. Congratulations to Mr. Dan Ludwig with DST Systems in St. Louis, Missouri. Dan was in our audience for show number 207, DB2 News from the IBM Canada Lab with Les King. And he completed the survey at the end of the show. His name came out of our lucky hat, and he's going to get a $25 Amazon gift card just for sharing his feedback on our show. We appreciate your completion of those surveys. Here's your giggle of the day, and it kind of relates to Mike's presentation today. If you only focus on the problem, you might miss the easy solution. And Mike's going to be talking to us about finding problems. So that's pretty funny. Like, duh, cat, just jump out. Okay, giggle of the day is done. Moving right along. 10-minute triage, troubleshooting DB2 LUW production issues with the one, the only, the super famous Michael Krafick. Michael, let's make you the presenter.
Okay.
Click that button and we'll get to see your screen. Looks like an iDoug presentation. I see your Twitter handle is @mkrafick.
Perfect.
Okay. Take it away, Mike.
All right. Hey, everybody. If you are first time tuning in or you haven't met me before, my name's Michael Krafick. I'm actually a lead DB2 database engineer based out of Atlanta. I have been doing DB2 for close to 18 to 20 years now, with about 3/4 of that time in production support and the last 3 or 4 on more the application side of the house. So I've taken a lot of my past experiences with my production support role and put together kind of a how-to, or how do I approach troubleshooting the problem. And this was actually it was actually inspired by Steve Reeves, who came out with a white paper a while ago on how to best troubleshoot areas. How do I look at all the various different metrics that are out there and hone in on the problem? And so I took a lot of his work, which is going to be sourced, and put it together with my experience and kind of came up with this how-to. So in the objectives today, we're going to talk about why it's so important for speed of recovery. It depends a lot of where you work. Sometimes everybody's running around with their hair on fire when production is down, and in other cases, people don't really care. And we're going to talk about why it is important to get up quickly. We're going to talk about what is normal and how to compare it to whatever metrics you're seeing with efficiency or pain. And you can't troubleshoot or start looking at the problem until you know if this is outside of the bounds of what you would normally expect. And you would be surprised how many people don't know what is normal. Once we get to where we can gather the metrics we need, we can identify if there's pain. We're going to be talking a lot about how we have common bottlenecks and the ripple effects, because a lot of times you may see a symptom, but it's not root cause. And then we're going to talk about developing an assessment plan and a general plan of attack or triage toolbox when you're attacking a problem. So the cost of downtime. This is why I was inspired to write this. I had just taken a job in the financial industry, and after about 6 weeks, I was being put on pager rotation for the first time. And I remember my boss going, "Hey, Mike, before we get going, can you remember $237? Like, yeah, sure, why? And he goes, because of every minute we are down, it's going to cost us $237 a minute in penalties. So take out the fact that we have clients we could end up losing, or disgruntled workers, or the fact that we are actively paying somebody and they're now idle. Forget any other penalties our clients may have to pay. We purely have $237 a minute in penalties." And that kind of intimidated me, but it also put things in context, because my SLA when I was on call with production was that I had to be on the right proper server, take an initial look, have a good idea of what's going on by 10 minutes, and hopefully have it solved by 15. And if we were getting to that 10-minute mark and I couldn't say I know what the problem is and I am solving it, other team members from different disciplines were paged to go through a checklist. So networking could get paged out, this could get paged out, the system operators could get paged out, and they had to go through their own checklist. So this was a lot of pressure, because if I didn't clear that it was my side of the street quickly, other people were going to end up getting pulled in. And at first I thought this was an unrealistic expectation. I mean, seriously, 15 minutes from page out to having my laptop open to solving the problem. Well, I learned that it is absolutely possible, but you've got to be prepared, and I'm going to show you how to do that. But then it also put in perspective why everybody's hair is running on fire. If you take a look at just the penalties, think about how much that costs. So just in the 15 minutes that everything went perfectly, my phone went off, I've solved the problem in 15 minutes. If I do everything perfectly, I could go buy 1 to 2 MacBook Pros. In 30 minutes, I could pay the average salary before taxes of some IT person. And how about 4 hours? That kind of blew my mind, that I could send one of my daughters to college for 1 to 2 years. At 12 hours, I was starting to run out of ways to do comparison, and my son walked by and goes, "Dad, I want tacos for dinner." So I took it upon myself to figure out the average cost of a Taco Bell taco and see how many I could buy. And then finally, after 24 hours, you could absolutely buy my house. This is why everybody is upset and running around. Now, on the flip side, I've worked for other companies where the software was ancillary. It was an auxiliary software. It wasn't used all the time. So the first time that I was paged out at my lunchtime and I come pulling into the parking lot and skidding out and hauling butt into the computer and trying to solve the problem, everybody's wondering why my hair is on fire. Well, I'm still in the $237 a minute mentality. But their SLA at that point in time was, it's just got to be up in 4 hours. It depends where you are. Regardless, it helps to be prepared. So what is normal? because it's not the person that's calling you now that's screaming that things need to be fixed. And this really is around the not my circus, not my monkey mentality. If you know what is normal, and as soon as somebody comes to you with what the problem is, you can usually tell quickly whether it falls within your wheelhouse or not. So what is normal? If I went to one of you in the audience and said, look, we have 750 connected users at 10 a.m., could you tell me if that's normal? If at 3 in the afternoon I said your data disk was spinning at 4,000 IOPS, could you tell me if that was normal? And you'll find that many can't. And as I was doing research for this presentation, I was struck by this quote: information is important for capacity planning and trending. And we all know that, right? Organic growth, but it's critical in a disaster. And the person that said this was the head of FEMA. And for those that may not be in the States, the head of FEMA is the organization that is deployed during a disaster, such as a hurricane takes out a city or tornadoes rip through a couple towns. FEMA is the one that comes in and assesses what's going on and gets the resources and the people to repair out where it needs to be. And what I thought was interesting, because I had a friend that told me about this, and then I actually saw it in a tweet later, is FEMA looks at a bunch of different metrics to see what is normal. And one of them is Waffle House. For those that don't know what Waffle House is, it's a restaurant that actually started in the South in Georgia, near where I live. And there's one on every corner. It is a greasy spoon that serves waffles and hot dogs and hamburgers, and they are open 24 hours, 7 days a week, all year. They are open at Christmas and Easter and 4th of July. They never, ever close. And they're usually the last to close and the first to open in a disaster. So FEMA actually look at them as a metric to see how bad things are. How many are open? How many are closed? How many recovered quickly? And I thought that was really creative, because as you figure out what your normal is, you'll also start to develop your own Waffle House metrics. So let's define normal. Normal has a couple characteristics, and Steve Reeves is the one that relayed this. It's got to be easy to collect. My argument to you is, if it is more than a few lines in a script or a simple to moderately complex SQL, if it's beyond that, it's not something you want. I should be able to write up what I want within 15 minutes, and my wrapper script shouldn't be that large. If you're going beyond that complexity, it's probably something you don't need for this purpose. The other thing is it needs to be easy to understand. When I look at it, there is no math in my head. I know good or bad or warning. It needs to be relevant to what I'm doing. So that is, what is my purpose? Is my purpose for organic growth and to see what's coming, or is it to triage and tell me there's an actual problem going on now? Those are two different types of metrics that you would want to collect. And then it needs to be sensitive without false alarm. You do not want your pager going off at 3 o'clock in the morning just because there was a workload change which caused your metrics to burp. And it takes time to whittle down and meet all of these needs. And my argument to you would be that I say you can do this and monitor your database with between 10 to 15, 18 different metrics on the high end. You'll find that with what I'm looking at, it has a tendency to be a lot less, because there may be a metric that allows you to collect information, let's say around memory, and there could be 2 or 3 of them. But instead of monitoring all 3, I find the one metric that meets all of these. It's easy to collect, understand, relevant, and isn't sensitive. So you can narrow down what you need. The other thing that you've got to watch for is your footprint. And when I talk to management, especially when we're in the era of big data and data lakes and get me all the things, if you talk to management and they start to see that you're setting up monitoring, they get real excited because they're like, I want to gather all of it. I want all of the data. This is fantastic. I want nice, pretty dashboards that are different colors. I want to see everything. But they don't think about the footprint that leaves. Yes, I can go get that information for you. But as I was assessing a tool many years ago that was specifically for emergency situations, one of the things they said is, be careful when you light this up. It can take 10 to 15% of your available resources. Well, think of context. If this tool was meant for emergency situations when your server is hurting, do I want to add another 10 or 15%? It could knock me over. Or if I'm going to gather all of the metrics I can because management wants it, how much pressure is that putting on your database? I would say you want to go in and you want to be a SEAL team, not a stormtrooper. So if you can imagine a room and there are two doors on opposing sides of the room, that I could open up the door, walk into the room, and immediately across the room there's another door I could open and leave. Picture that scenario. And then in that room, let's pretend I have a single bullseye on the wall. If I came to a SEAL team and said, I want you to go in and hit that bullseye and get out, you would see 6 guys line up behind the door quietly. The door would open. They'd each funnel in one at a time, take a single shot, hit dead center, leave the other side of the room through the door, close the door. Nobody knows that they were there. All 6 shot hit dead center. But if I went and had stormtroopers go in, you're going to have 25 of them open the door. They're all going to go in, shoot 100 times. Everybody's going to miss the target. A few of them are going to shoot themselves. They'll leave out the other door, and it's going to be a train wreck in there. That's because they were trying to do everything. They weren't going in with a purpose. So when you're going in to get your metrics, you want to approach it as if you're a SEAL team. Don't go in and shoot like a stormtrooper. So how do I snipe those metrics? Well, there are 3 different ways you can come at getting metrics to show you efficiency or pain problems. And most of us focus at the database level, but I want you to look outside of that. If you did the database level, you can come at it from a couple different perspectives. The performance, how have we been and where are we going? The pain, this is your early warning system where you're getting paged out. And configuration, do you have drift? You've got to be careful. Am I where I'm supposed to be? But you can also look at the application level. And most of us think that this may be a key performance indicator for the business. Do I really care about abandoned shopping carts? Well, maybe that might be the first sign of a problem coming your way at the database level if you can link the two. And then operating system and the server level. I actually prefer these over database level, especially for pain metrics. The reason being is the database is greedy. For example, with memory, the database will eat whatever memory you can give it. So the server is constantly trying to make DB2 and the database happy. And what I have found is that in an effort to make the database happy, the server gives of itself more and more, and it will start to feel pain before the database starts to feel pain. So you can grab these metrics from any of 3 different directions. So let's talk about what metrics that we're going to monitor. And I really struggled with this at first because I was trying to use a ton of metrics for too many things. And I had to change my approach and go, look, I've got 2 distinct purposes. I have those things that I am looking at on a monthly database to watch and see that something's coming. And then I have those things I'm monitoring all the time that alert me pain is here and there's a problem. And once I had those 2 defined roles, I was able to, it was a lot easier for me to break down what I needed to monitor when. So efficiency metrics are going to show stress. This is going to show you that slow build before you end up breaking. What am I watching? Well, not that much if you look at it. For example, if I am collecting the top 10 SQL by number of executions or execution time, and I do that every month, and then on my 4th or 5th month, I see the top 4 SQL change, I know something's been introduced. What's going on? Do I need to pay attention? My IO wait time, is that creeping up over the past few months? it may not be tipping anything over now, but I've noticed that my IO wait time has doubled from January until now. What about my locking situation? Or how long I'm staying inside the database versus how long I'm outside the database? But the two that I think are the most important are the average result set size and index read efficiency. And the average result set size always provides me context. If I know on average, it doesn't matter how many thousand SQL I run, that I am usually bringing back less than 10 rows, I know my database is performing like a transaction processing system. If it's bringing back 1,000 rows, I know it's behaving more like a warehouse. It's a big dump truck. I'm not that slow, but I'm going to bring you a lot of data, as opposed to the Ferrari that's very, very fast. If I see that average result set size change over time, we've had a deployment every month for the past year, and that average result set size is creeping up from 10 to 25, hey guys, we're changing our workload and our behavior. And then index read efficiency is one of those indicators that I see as a problem first. If my index read efficiency is starting to change over time and get worse and worse and worse, I will see that happen before I start seeing CPU errors or deadlock errors or memory issues or inside-outside time issues. And index read efficiency was actually developed or discovered, I would say, by Scott Hayes. I learned about it about 10 years ago. And the theory is SQL comes in, it does a certain amount of scanning to get the one row it wants. How effective is it? Is it using an index at all? Maybe not. If it is the index useful? So am I going in and reading 2 rows to select the one row I want? Or am I going in and reading 2,000 rows to select the one row I want? And index read efficiency and average result set size are actually together. So this is where I differentiate a little from Scott's teaching. Index read efficiency has some rough rules of thumb. So I know if I'm reading less than 10 rows to select one, I'm really doing well. If I'm selecting, let's say, 1,000 rows to select the one I want, I'm doing very poorly. And when Scott was originally teaching this to me, and even in some of his writing, you're going to see he's got some hard and fast rules here. And what I said over time is put it in context. If I know my workload is transaction processing, and I am constantly under that less than 10 rows selected for any SQL that comes in, I'm going to hold to my IREF metrics really hard. I'm not going to mess around. If I am selecting more than, if my IREF is 15 instead of 5, I'm going to sit there and go, this is transaction processing to the core. I'm really going to take a hard look at this SQL. But if I'm starting to develop a mixed workload because I'm transaction processing during the day, but in the evening I end up doing a batch workload, I'm going to sit there and go, yeah, well, my IREF is creeped up to about 60, but when? Let me put it in context. So the closer I am to transaction processing, the more strict I am with my IREF output. But the closer I get towards warehousing, the looser I am. And if you are pure data warehouse, I pretty much throw it out and make my own normal. Because sometimes when you are doing pipeline reports that take 5 days to run for all of management, and you're on average doing you're doing IREFs of 1,000, but that's the best you can do, and all your other metrics are green. That's my new normal. So index read efficiency and the average result set size are the two most important metrics for me when I'm looking at efficiency. Now let me show you how that flushes out. In this presentation, you're going to see I'm using Brother Panther. And that's because it's the easiest way to show you correlation between one metric and another, where you can do this by your own scripts. Matter of fact, I will show you where to go to get some of that. But for the purpose of this demonstration, I'm going to show you through Brother Panther. So let's take a look at some testing that I was doing. A new SQL was being introduced, and we ended up rerunning some normal load tests. And the new SQL we introduced were fine. What caught me was behavior in some of my original SQL had changed. So if you take a look over here where it says index read efficiency, let's look at the second one right here. This is a select statement, right? On average, I am going out and I'm reading 1,473 rows to select 1. And I am running this SQL 733 times. How about up here in this update? I'm going out and doing some sort of read where I have to read 200,000 rows to select the one I want. And I did that 726 times. And in this hour workload, when all the SQL ran, these SQL here, which are not efficient, are consuming 77% of my CPU. So this is a good example of an efficiency metric that was catching a problem before it became a pain metric. I am not efficient. This is where the bulk of my CPU is working. And for now, that's okay. This is the bulk of where my time is spent, is just on these two SQL. And you wouldn't even know this is a problem because the average exec time is sub-second. So this is a case of you don't have one big elephant coming into the room and stomping on everything. It's death by 1,000 mosquitoes. If you get bitten 1,000 times, it's going to hurt. And that's what you're seeing develop here. So my first thought when I saw this is, oh, great, I'm going to have to either rewrite some architecture or come up with an index that's going to be huge. And I went in and said, well, DBI, show me what my index options are. And I have an index that's less than a meg that can give me a 99% improvement. And look at this. I wouldn't even normally blink at SQL that was only 13 time runs. But I know because of its weight and its index read efficiency how much impact it's having. So I came up with a new index. My concern was, is it going to harm anything else? Well, what I liked in the newer versions of Brother Panther is you can say, take a look at not just my hour. Take that index and apply it over the past 8 hours and tell me if it helps or hurts anything else. And in my specific case, it didn't degrade anything. It specifically went after the indexes that the SQL that I was doing. And look at its effect. Here are the same 3 that were highlighted before. Now we're reading on average just 2 rows to get the one we want. Our percentage of CPU time dropped. We're not consuming a ton of CPU. And we were able to get a ton more executions in the same amount of time. And then I was able to go back and say, well, how much did things improve, and do a side-by-side comparison. So I could see the improvement of index read efficiency. And you can see how it drops over time. What I showed you was in Brother Panther. There are articles that Scott's written about how to do this. I've even written an article for datageek.blog on it. But I also created a YouTube channel that's out there. I think I'm on 25 or 26 videos now. I specifically spent time on this topic about what is index read efficiency, how do you compare it in context, here's some SQL to help you go get it, here's a GitHub repository with a bunch of information in it, here's a bunch of links that will help you. This is a good starting point. So if you don't have Brother Panther, which will make this 10 times faster and easier, you do have options. We talked about efficiency. That was seeing the problem coming. What is my canary in a coal mine? What is the metric that I'm looking at to signal that there is a problem? This is my page out. Some of these seem obvious, some don't. I have gone into shops where I'm taking over and go, wow, you are not contacting anybody or monitoring to look to see if the database is even up or down. I have been in places where the database is run for so long, nobody pays attention to it, yet HADR failed from primary to standby 3 weeks ago and nobody has figured that out. I go out and I look at active connections. I know on average how many of my 100 connections are active at any one time. If it starts getting unusual, alert me. What about my table space state? Am I being locked out? And here, for example, swap space utilization is my Waffle House metric. You remember what I was saying before, we're looking for CPU, we're looking for disk utilization, and then you don't see anything in here about memory. I don't monitor buffer pools. Buffer pools was one of those that were too sensitive for me. They were constantly setting off false alarms. But I needed a way to take a look at how memory was being used or if it was becoming a problem. And that's when I noticed swap space was something to monitor. Swap space is an area of disk on the server that the server will start to treat like it was memory if it's running out of memory. So the good news is things keep functioning. The bad news is every time you spin disk, you are slowing down. So I said, look, if I see swap space start to creep up, that's my new metric because I found it wasn't causing a false alarm. And it also goes to that theory I told you that the server is going to try to give its all before the database starts to feel pain. So if there's a memory problem, I'll see the server start to go to its swap space before DB2 starts to hurt. The problem with swap space that you need to watch out for is that I found it's usually not a spike. Like CPU can spike from 10% utilization to 90. Swap space is a slow creep. So when it does alert me, I get to it very, very quickly because it meant that it had been building up. The other thing with swap space is it doesn't clear, at least not quickly. The OS said, I had to use this at one point. I'm not going to give it back because I might need it again. But it will slowly give swap space back and bring the utilization down very slowly. Like I've seen it take a day or two for it to completely come back down. If I want to make sure that metrics reset, I often ask for the server to be restarted. What do you do? How do you notify yourself? Well, with your pain metrics, at least in my experience, I will say, look at these pain metrics, email me if they're non-prod. I want you to email and I want you to call me out if they're prod. But I also make it so I can easily assess it at any time. On one of my monitors at home, I have this dashboard up 24/7 to the point that when my kids wander into my room, if they see one of the check marks change, they come get me because they know red is bad. So it's quick, it's easy to gather. I don't have to think about it when it's there, and it tells me immediately. This is a quick response thing for me. And you could be mining data anywhere. You can be hitting the repository of Brother Panther. You could be pulling from your own scripts. There's all sorts of ways, but a dashboard is a phenomenal thing to have. All right, Mike, you've talked a lot about these cool tools that go grab this stuff, but you also want me to go get these metrics and hold them historically. I don't have a tool that can do that. Well, you can always engage a vendor like DBI, but if you're in a small shop and you need to create something on your own, you don't have to go from scratch. There's a couple different articles out there. Abek Roy wrote 3 articles for datageek.blog on how to use Workload Manager as a monitoring solution. And then there is another article out on DeveloperWorks on how to reset monitoring table functions. And you can script that and plop things into your own homemade tables to monitor off of later. But I was ending up using DBI, I had mentioned, because A, it's a small footprint. I know what it'll do to my system when I turn it on. But those canary in a coal mine that I depend on so much for early warning, the index read efficiency and average result set size, they're all there. I found that this gave me a good picture quickly. All right, we have our bottlenecks. Hey, Scott, we're about halfway through. Do you need time for a break, or do you want me to keep moving forward? Sounds like
Microphone activated. Yeah,
there we go.
this is a fine time for a break. Get you a chance to rest your voice and have a sip of Coke. Do you have a Coke there?
I'm pounding water. I need Coke badly, though.
I'll fax you over one.
That'll work.
Okay, make presenter. Let's ask our audience some questions. First polling question: what Db2 LUW versions are you currently running? Let's find out where we are in the world with Db2. Our good-looking audience is voting. Very nice audience today. Beautiful people in the audience. We'll let this go for 30 seconds or until 80% of the audience votes, whichever comes first. Giddy up. Click the mice. Let's find out what version's going to win today. Going once, going twice, closing the poll, sharing the results. Answer is 10-5 by a very narrow margin, 70%, 67% on 11-1.
Wow.
22% on 10-1, 44% on 9-7. That was a beautiful release of DB2, one of the most beautiful releases of DB2 IBM ever gave us. And 15% on 9.5 or earlier. Okay, well, I think 10.5 is going to be end of support next year. Time to giddy up, people. Next, what operating systems are you using to run DB2 in production on? AIX, Windows, x86, Linux, Z-Linux, Linux on Power? Yeah, I know there's Sun and maybe some others, but GoToWebinar only gives us 5 choices that we can offer. So we'll see. You know, it used to be a sure thing that AIX was always the winner on this polling question. If you've been following the Db2Night show over the years, we've been asking this question a long time, and AIX was always the winner. Remarkably, going once, going twice, going 3 times, closing the poll, sharing the results. This is different. Last couple of shows, x86 Linux has taken the lead over AIX as the most popular production platform for Db2 LUW. 23% on Windows, 10% Z-Linux, that's a great platform. 3% Linux on Power. Closing the poll. Next polling question. Well, would you be interested in watching Db2Night show replays on YouTube? Are you a YouTuber? So we've had these downloadable files, the WMVs, the MP4s, forever. And then some people said, yeah, I just want to stream it on YouTube. And YouTube certainly is convenient if you have access to Wi-Fi on your devices. Yeah, it's funny. This is interesting. Couple more seconds to go. Going once, going twice, closing the poll, sharing the results. And people do like, yes, 13%, yes, definitely. 7% are firmly in the, I'm going to download the files. And 80%, both YouTube and downloads. Yep, it's good to have options. Well, if you noticed on our prior show, the DB2 News from the IBM Canada Lab, we actually have that show on YouTube, and it's embedded in the replay blog so that you can find it easily. And we'll put today's recording on YouTube as well. Okay, next question. Are you using DB2 and that fluffy cloud thing? Kind of watching the adoption or resistance of cloud. We got the AWS cloud, we got IBM clouds, we got other clouds. Thinking about clouds in the future. No way, no how, not for us. That's entirely valid. And now IBM's got this ICP, IBM Cloud Private. Yeah, it's like a cloud, but we're going to sell you an expensive piece of hardware that you put in your data center, and then you get to call it a cloud. We've been doing this forever. I was running databases in the cloud in 1994 when I had to telnet and remote log in to a server at the other end of the building. It wasn't at my desk. It's a cloud. Okay, going once, going twice, closing the poll, sharing the results. Here's what y'all think about cloud. AWS Cloud is more popular than IBM's, 13%. Another cloud, maybe that's the Googly Cloud. 43% not yet, thinking about it. Just keep thinking. And 27% say, nope, not going there. Okay, next polling question. Are you using Db2 PureScale? I had 67% of our audience approximately on 11.1. IBM made a lot of enhancements to PureScale in 11.1, actually made it usable. Installation is now 6 steps instead of 37, so that's a really big improvement. And we're seeing an uptick in adoption of PureScale for those environments where extreme high availability is a requirement. Going once, going twice, closing the polls, sharing the results. Here's what your DB2 community peers say about PureScale. 10% yes, 27% not yet, but evaluating or planning. 63% no need at this time. Okay, that's fine. And that's it for our polling questions. Next, a quick commercial break from today's show sponsor, DBI Software, offering smarter tools for smarter people. We are quite honored. Yep, 5 years in a row, Database Trends and Applications magazine has named DBI as one of the top trend-setting products. That's 5 years in a row. Other tools don't see that recognition. Now, a quick demo. Here's DBI's brother, Panther, which is the centerpiece of the DBI Pure Feet solution, not Pure Suite, Michael, Pure Feet. And yeah, that's okay. Here's a database that we care about. So I'm going to view a performance trend. Mike's favorite metric is the index read efficiency. So I'm going to look at ratios. There's index read efficiency. And I'm going to look at a graph of index read efficiency for the last year, a 1-year trend. Let's see what happens. So Mike is talking about understanding what's normal. And here it looks like, I've got a very low data points here. And then I've got these spikes. These spikes kind of look like my normal high. And then there's this aberration here. Something happened there. Wow, that's huge. So then what we can do when we see a spike is we can draw a little rectangle around it and say, well, what was happening when the spike in index read efficiency occurred? And we just click on the little button here. This will show us the SQL that was running at that time when that spike in index read efficiency occurred. Ooh, here's some really big numbers on the index read efficiency and some slow response times. 35% of the rows read in the database during that time, 32% of the CPU. This guy's scary. Let's do a quick explain. I said quick. I haven't exercised this DB2 database in a while. It must be sleepy. Here we are. We've got join between two tables. This table scan is 99% of the cost. On that scan, we're evaluating the predicate domain name equal to something. So if I look at that table, I don't have an index on domain name. Domain name is 27,000 different values over 633. That's 4.2%. Probably need an index on domain name and maybe some other columns. Let's get an opinion on that from the index advice. Hopefully DB2 will cooperate. Beautiful. 6534 down to 21 and 99% improvement. Here's the recommended index. And that looks very nice. I can take all that cost out of my workload. But let's see, if I create this index, will anything bad happen? And that's the impact analysis that Mike showed you just a little bit ago. Now we have to reach into the workload and find all of the SQL that contribute I/O to that table. And it turns out 24 statements will improve. 11 will be unchanged. 1 statement will degrade. Huge CPU time savings, huge execution time savings. But what about this one that degrades? Well, that's going to scare people. So let's take a look. Down here, we got the 1 statement that degrades. I recognize this. This is a decision support query. It's not part of my transactional workload, so maybe I can get away with safely creating that index. Certainly for the huge CPU and execution time benefits, I'm liking that index a lot. If you'd like to see more, again, we have a webinar this afternoon at 1 p.m. Central, 2 p.m. Eastern, and I invite you to join us. That's going to be great. Mike, I'm going to make you the presenter again.
Okay.
Oh, there's a question, though. I'm going to make you the presenter, and then we'll look at that question. It might be related to something somebody needs to know. When did God create the DBA? That was the question. That's just funny. When did God create the DBA? I'm going to Google that and get back to you. All right, carry on, Mike.
All right, so let's talk about bottlenecks. We know what normal is. We are historically collecting metrics. We know the difference between metrics. The historical, the efficient, and the pain, which is come out, we've got a problem. So what causes pain? Bottlenecks do. And I'm going to stop here for a second and say, if you do not have this white paper, this book, go find it. Best Practices, Tuning and Monitoring Database System Performance by Steve Reeves and his team. This is a Bible. It is also a thick and in-depth and fantastic. I am doing a 40,000-foot flyby on some of these topics here, but I'm actually going through it now and trying to develop my own type of script that takes a look at his decision-making process when he's looking at metrics to help me triage quicker. So I'm going to cover the main bottlenecks that he talks about here, but at a very, very high level. When you're dealing with bottlenecks and choke points, when you have a problem and you know it's down at the database level, it's usually because one of these 3 things: CPU, disk, memory, and locking, or that last one could be called a lazy bottleneck, which I'll talk about in a minute. What are the symptoms of each type and how can I find them? Well, let's take a look at disk. The 2 that I look at the most with disk is the disk utilization. How much is it spinning? Is it spinning 20% of the time or 50% of the time or 80% of the time? And what about my I/O wait time? Is the CPU sitting there and idle because it's waiting for disk to spin? Those are the 2 that I'm constantly looking at. But I liked some of the nuances he went and described a little bit more in his book. For example, is your CPU looking like it's suppressed? You know it could do more. It can go up to 70%, 80%, but it's not. It's hovering at that 20 to 50%, and things are still slow. That's the little stuff that I like to look for that will lead me down the rabbit hole. Yes, I may see my disk utilization is over 80%, but is my disk utilization over 80% and my CPU utilization suppressed? Okay, I've got 2 of the characteristics. Let me start taking a look at disk. How can I get there? There's a ton of different ways to do this. I like IO stat. IO stat's very simple. You give it an interval How long am I running it, and how many times am I doing it? And when I take a look at this, although there's a ton of different information here, I'd like to look at the I/O wait, which is going to show you the percentage the CPU was idle because it's waiting on disk, and the percentage idle. My CPU wasn't sitting there doing anything. In this case, everything is looking fine. You can break down to the device level. You can get in the weeds there. I would watch out for it. But knowing your transfer per second may not be bad if you can get a general average. CPU. You can saturate CPU in two different ways. Overall CPU saturation or a single CPU saturation. So when I say I have 2 CPUs on my box, but they're 4 cores each, there may be 2 physical objects there, but when I look at them with my tools, it'll look like I have 8. So a CPU with 4 cores looks like 4 CPUs in my monitoring tools. So when I'm looking at this, I sit there and go, are all 8 pegged at 90%, or is everything else fine and hovering at 30, but I've got that one single CPU, that one core, that is pegging at 95% or 100. That's the sign of a problem. I also liked the ratio that he hinted at in the book. What's normal between system and user? A 3-to-1 or 4-to-1 ratio between system and user isn't that uncommon. How can I get some of that information? VMstat. I use this. It does show me memory and swap and all the other stuff, but the CPU on the very end, it will show me how much I was idle, how much I was waiting, and what percentage was going on between the user and the system. So I can see that last metric that can give me a hint on the 3-to-4, 4-to-1 ratio. And this is the example of what you were seeing in Brother Panther. Remember, we caught the problem using index read efficiency, but we were already seeing in our efficiency metrics, we were putting pressure on the CPU. But later on, this could have developed into one of the 4 types of bottlenecks. Memory. Memory, most of you know, is very, very fast. And the problem you'll run into if your bottleneck is a memory is that there isn't usually enough allocated for whatever type of task you are trying to do. Every time I blow out that memory and I have to flush it and put something else in, that's an extra step. Or is my memory so small that I'm forcing myself to go out to disk because I can't pull it into my buffer pool. When you're doing that, you start to slow down. So memory, in my opinion, is actually one of the tougher bottlenecks to find because there's a bunch of different pools that you can take a look at. And I find I honestly don't normally have memory issues because one of the cheap things that people or the system admins will throw at a box is memory. What's an easy way to assess it? Well, my favorite is top. It will show me how idle my CPU is, but I like how it displays the memory, specifically the swap space, how much is it used. In that middle box right here, 7756, when I start seeing that creeping up anywhere near the total is when I start to get upset and look at things. I also love top because it will show me what is chewing up most of my resources at the time. If DB2 sysc is at the very top and it's consuming 80% of my CPU, I know the processes within DB2 and DB2 is what's chewing things up. But I've also had backup processes and networking processes. So if I see my CPU is spiked and DB2 top is showing my top 2 commands are not DB2 and it's chewing up CPU, I know I'm not the process. I like the fact that it's very quickly to interpret. Lazy bottlenecks. Lazy bottlenecks is when the application is going, come on, man, work faster. I'm waiting on you guys. And you're looking at the box and you're looking at DB2 and everything seems fine. Your CPU is fine, your memory's fine, your disk is fine, nothing looks out of whack. Well, that's because you're inside DB2 and it's tripping over its own 2 feet. If I'm dealing with lock contention, it's, hey, Mike, I really want to go get that information, but I can't because I got to wait for this other lock to clear. Or prefetching isn't sufficient, where DB2 is normally very effective at pulling things off of disk into memory so you don't have to go spin the spindle somewhere it's just not doing that effectively. So I have to take the extra step and go out and spin disk, which is slow. There could be a couple different reasons for lazy bottlenecks. But one of the biggest bottlenecks, the biggest lazy bottlenecks, I would say, is locking. And there are a couple different ways to go about that. I'm a teacher that likes to teach the hard way of doing things first, so you could always go back and do it. There is SQL you can go look at that will give you lock weight information as well as what's in the lock chain. And it can go and give you what object is in this contention. This is very, very useful. I love the fact that it'll give you the lock weight start time. It'll tell you who is wanting the lock and who is blocking the lock. But this also isn't the easiest to do or the quickest. What I like to lean on for locking is Db2 Top. Now, I will state that Db2 Top has been around for a while. As of 11.1, it is deprecated, which means it is still there. They're just not working on it anymore. It's being replaced with DSM Top, I believe. Db2 Top is every DBA's baby. We love it. Matter of fact, if there is any IBMer listening to this, let me please give you a public service announcement. This is our baby. We love Db2 Top. Do not plan on taking it away from us unless whatever you are giving us is 10 times better. If we lose our Db2 Top and DSM Top isn't as good, we will riot. We will storm the labs with pitchforks. It's going to get ugly. So please, please don't take this away from us just yet. If you need to go look at locking, hit U, and U will show you what is locking. Now pay attention, kids. You see this lock mode right here? You're going to have to know what IX means and S means, because just because we see it has an X in it doesn't mean it's necessarily bad. And is my lock being shared? What's going on? Am I waiting over in the application for something? You're going to have to know how to interpret this. But if you go hit L for lock chain because you're not sure, the lock chain will show you, hey, process ID 38 is blocking process ID 40. Okay, now I know I'm actually starting to back up here. And it will also tell you how many locks are held, but it doesn't say what deadlocks are going on, pardon me, or what's really being blocked up. I also like the fact that there is a bottleneck option in Db2 Top. The bottleneck option in Db2 Top will show you all the different places within Db2 you could start to get hung up. Memory, locks, my sorts, my overflows. You don't want to panic here. If you took a look at this immediately, you might say, oh, I'm spending an awful lot of times in my logs, or I've got an awful lot of locks going on. This thing is refreshing, I think, once every second. So sit and watch. In a healthy environment, you're going to see those numbers flip and flop and change and high and low because work is going in and out, in and out. And this is just a picture at that snapshot of time. But if you've been sitting there watching the meter for a minute or two and you're seeing that we're consistently staying at around 71%, we're going to 80, we're going to 90, okay, now you can go hone in on there. So Db2 Top is really good at helping find the locking lazy bottleneck as well as an overall picture. Here's an atypical lazy bottleneck. This is mine. I am throwing it in there. And this is for those that are on bigger systems in which you have multiple table spaces, and those table spaces are holding certain tables but not others. I was running into a situation where I was getting really strange feedback that, hey, this query is working, but this query isn't working. These apps are getting responses, but these apps are not. And what I had found out is one of my table spaces went into an odd state. So unless you were hitting the table in that specific table space, you were not affected. That's why some people were okay and some people were not. So I had to start watching for things like, am I in backup pending because some joker did a load the wrong way? Is something quiesced for a tool? Or did disk crash that only affected certain table spaces, which meant only other certain tables? So the symptom I was seeing was intermittent access, or the problem didn't seem to apply to everybody at one time. It was really strange to track down at first. Let me give you some SQL that may help you out with this stuff. These are things that I've either developed hooks for and thrown to my dashboard that you saw earlier, or to a monitoring tool that will page me, or to an email. I've got all sorts of homegrown scripts. But if you want to catch the table space state, here's something that you could use to develop your own hook. You got a bunch of different states, so I wanted to point out, if you're normal, backup in progress, load in progress, reorg in progress, these were things that I wasn't worried about alerting on. So it's, as long as you are normal or one of these others, everything's accessible, don't alert me. Otherwise, alert me. How do we triage the problem? First of all, question everything. I have a running joke with my wife now that is, don't trust the testimony of a 6-year-old. You need context. So I will say, unless this is coming from your own monitor or it's coming from somebody that understands the business side as well as the technical side, you need to be asking questions. I hate it when people come to me and say things are slow. If you can't tell me when or what you were doing, or if it's affecting only you or others, you're doing no help. Don't look for a needle in a needle stack. So when you come to me and say things are running slow and I have no point of reference, I'm just generally going to start looking at all the data, the giant data lake, and figure out what the heck may be wrong. Now, if I'm doing this properly and I know what is normal, it may stick out, but always ask the question, who, what, when, where? Do you have any more details? And if it's coming from somebody that's technical, do not come to me unless you can give me a SQL code. DB2 will always give back a SQL code if there is a problem.
Don't trust the testimony of a 6-year-old.
Don't ever trust the testimony of a 6-year-old. Don't trust the testimony of a developer. Yeah, great. All right. So let's see if I can get you to the end here. Listen to what the patient's telling you. One of the things that I ask people that are interviewing is, here's a hypothetical situation. Go out and tell me how you would troubleshoot or triage this problem. And I hear some really elaborate feedback, and they always forget, go talk to the error log. Look at the error log. The error log will tell you, you are being stupid, and this is how you're being stupid, and this is how you can fix it. So you can go on some elaborate troubleshooting mission, or you can go to DB2 and ask it what's wrong. There are multiple ways to do this. If you're like me and you've been doing this 20 years, you're still being stupid and tailing things or looking in VI, but make it easy on yourself. There are DB2 diag commands, or you can say, show me everything in a nice, neat table on how things are being done. The other interesting piece, or for those that may not be familiar with a diag log, I'm going to brush over this real quick. There are a couple things that I'm always looking for in here. One, is it an error? Two, where is it coming from? Here I have an IP address of 0, but it'll usually give me the IP address of the application that's coming in. I know who is doing it. And I look for things in the message that'll give me a quick hint, including a ZRC code. ZRC codes are almost as good as SQL codes. And here is a good example. If I know what my ZRC code is, and I type db2diag-rc and give the RC code, it will give me a lot of information, including the SQL code and what could be going wrong. I look at this sometimes because I have seen the application get ZRC codes, but not the SQL code. And if I have one or the other, I can get to information I need. For those of you that don't want to go out and Google, if you are command line, and you type db2 space question mark space and the SQL code, it will give you a ton of information on what the problem is and how to respond. I will tell you though, that if you have like a Dockerized version of DB2, or it's a non-root install, you lose this ability. So it's really helpful. I can quickly look things up, but if it's a non-root install of DB2, you lose the ability. Here's another trick. If you get SQL code -291 back from the application, or you see only -291 and you suspect it's an error code, you can always take that information and plug it into this format to get the SQL code. So if it's 3 digits, move it over, pad it with a 0, tack on SQL and N. Whoa. and you'll get the information you need to look up. There's a lot in exploring the DB2 error log. This is another episode I did on Discover DB2. Please feel free to go out and take a look at it. We went and did about a 15-minute deep dive in just to the diag log itself. Give me all the metrics. Remember, I've been telling you, avoid gathering everything. Avoid the big fishing net. Sometimes you just need it because you have to look at things in context. I want to see how my locking is linking to my application connections, linking to my IO wait time, and I need everything in one shot over the same period of time. MonReport DB summary will give you that information. Now, I could go do a whole presentation just on this, so I'm going to rip through just the high level. Really easy, call DB summary and the number of seconds you want to run, like 30 seconds or 60 seconds. It's going to put out a ton of useful information. Hey, there's my IO wait time. Look at my buffer pool hit ratios. It'll tell me how I'm locking at that time. How many rows read and rows returned am I doing? My average result size, right? Now, something to watch out for. We've talked about collecting all these metrics, including DB summary, because DB summary will give you a lot of cool information on your disk and your IO. I want to point out that if you are on a VM or especially cloud computing, if you are not isolated, if your disks are not isolated, you've got to take everything with a grain of salt, because at the disk level, A can affect B. If I'll relay what happened to me. I had a highly transactional system that did online banking. I had a warehouse. They were on separate LPARs, separate servers, but they shared the same disk backend. And I couldn't figure out that why once a month on what seemed to be a random day, my transaction processing database would go in the tank for 12 hours solid. And it took everything I had to keep it up. None of the metrics made sense. Long story short, we found out later that the data warehouse on a certain day of the month would spin up and start running its reports and hitting its separate database. The problem is the disks were intermingled on the back end. So when the data warehouse started spinning disks hard, it slowed down the transaction processing. And here's the kicker. In the back end, you've got all sorts of caching and monitoring and hotspot monitoring, right? And we weren't tripping the hotspot monitoring. My transaction processing was so sensitive that it would start to feel pain before the disk thresholds were tripped to tell storage that there may be a problem. So if you are not isolated by yourself, your metrics are always suspect. You could be affected by somebody else that's doing work. Assessing the problem. We're in the tail end, guys. There is an easy flow chart. The book that Steve Reeves wrote goes into it in a lot more detail. But I can go through and systematically ask myself questions and tell you within about a minute whether the problem may lie with me and give me 5 more minutes to look at it, or the problem looks somewhere else, lives somewhere else. First thing, is the error log clean? It will always tell you what's going on. Is there evidence of a system bottleneck, my CPU, my disk, or my memory? What about a lazy bottleneck? Am I seeing anything with my table space states or my lock? And more importantly, is my inside time normal? If SQL is normally inside in less than a second, and I have not seen that change, that's a really good indicator to look up. The problem is above you. But what if I have a problem? Then go through the 4 types of bottlenecks that you have. CPU, weird? Go look and see how many connections you have. Or did you suddenly change how memory is handling work? And a ton of work's being in memory now, so CPU naturally spikes. What about the disk? Am I running on old stats? Am I blowing out buffer pools? Memory bottleneck. Do I have my instance memory is capped and I'm hitting the instance memory? What about the other lazy bottlenecks? Do I have enough prefetching going on? What about my table spaces? You can go through this checklist and narrow down pretty quickly. Finally, guys, I mentioned that there were a ton of resources out there. I've got a lot going on Discover DB2 on YouTube. Feel free to check it out. If I did anything there that had a script or SQL I thought can help you, it will be out on my GitHub repository. Just to give you an idea, I have scripts on scripts on scripts out there that can help you. How do I quickly revote things from public? Look, here's my index read efficiency SQL. How can I go count my locks by hour? You've got a ton of resources out on my GitHub repository that can help you. And finally, as I mentioned, check out Discover DB2. I have a bunch of different topics out there, from the very basic, like how to catalog a database, to mid-range, like how do I effectively do reorgs, to complex, like how to write my own Docker file for DB2. And that's it. Thank you for letting me speak.
That's it. That was awesome. Wait, let me get you a big old wow. Wow! That was great.
Thank you.
Okay, we're going to wrap up now. Oh, show my screen. Back to the presentation. Here we are. Time to wrap up. We need to ask a polling question. Polling question asks, did you learn anything today? We always ask that. Did you learn anything today? Hopefully people learned. Good job plugging that great work you're doing on Discover DB2. There's some great videos there, and they're just the right length there. Some of them are short, some of them a little longer, but you know, if you've got 5 to 15 minutes to spare, fire up a little bit of Discover DB2 and learn something from Michael. Okay, well, this is pretty awesome. 100% of our audience learned something from you today, Michael. Well
awesome. I'll take
done. Well done. Fantastic presentation. And so we remind everybody to please complete the survey when today's show ends. Thank you very much for joining us today. We love our live studio audience. Beautiful people. Great questions. That's a little Q&A going on there. And thank you, Michael. It's great having you as a guest.
Thank you for having me.
If you do me the favor of sending me your presentation as a PDF, I will include it in our replay blog so that people can reference your PDF and all the great information you shared today.
Definitely, will do.
Okay, well, that's it. I wish everyone a happy and safe weekend. Bye for now, and hopefully we'll see you at 1 o'clock this afternoon as well. That's it. Today's show is sponsored by DBI. DBI is your trusted partner for breakthrough DB2 performance solutions that deliver invaluable results for organizations having the most demanding requirements and discriminating preferences. Yep, tools for smart people who want to have awesome results.